Alright, this is a lesson on elementary probability or basic probability. And the probability is defined as a fraction. It's a fraction of how many, let me rephrase that. The probability of an event A is defined as a fraction. It's the number of outcomes in A, whatever A is, and we'll look at some concrete examples in a little bit, divided by the total number of outcomes. So if you can get those two numbers, put them in a fraction, then you can get the total probability. Now, the number of outcomes in A will never be more than the total number of outcomes, and because of that, you find that your probability will always be between 0 and 1. It's always going to be positive. There is a possibility it's 0, and if it's 0, then it's never going to happen. It's impossible. There's also a possibility that we get 1. That's if the numerator and denominator are the same. But just keep that in mind. If you are doing some work and you get a probability that's 3.2, you did something wrong, because the probability cannot be more than 1. Or if you get a negative probability, there's something wrong, because it's got to be between 0 and 1, or it could be 0, or it could be 1. So let's take a look at an example. Let's look at number 1. For each of the following events, list and count the number of outcomes it contains, and hence calculate the probability of each. Okay, so A is the event of throwing a 3 or higher with one die. So a die has 6 sides, and so you want to think, well, what are my outcomes, right? So for outcomes, for event A, well, 3 or higher would be a 3, a 4, or a 5. And then total outcomes, whenever you roll a die and you're not looking for any particular thing, you would have a 1 through 6. Okay, so if so I'm asked to list. So I listed them and count the number of outcomes. So we have 3 outcomes for A and 6 outcomes for the total. And so the probability of A here is going to be 3 out of 6, because we got 3 outcomes for A divided by the total number of outcomes, which is 1/2. And that's pretty much how probability works. So you got to be good at counting, and that's why we did the first 2 sections on the fundamental counting principle and combinations and permutations, because if you can count well, then you can find out what this fraction is. Alright, so let's take a look at B. Throwing exactly 2 heads with 3 coins. So if I have 3 coins, so for B, I'm going to write it a little differently now. So possible outcomes would be heads, heads, tails, because I want exactly 2 heads, or heads, tails, heads, or, oops, didn't want to close that. There's one more case. Maybe you know what it is. That would be tails, heads, heads. So there's 3 outcomes for B, and then the total number of possible, or not the number of possibilities, but the total, I'm going to list out all the possibilities, which we call the sample space. So I'm going to put S for sample space. So we have these 3. I'll just recopy them. So heads, heads, tails, heads, tails, heads, tails, heads, heads. So those are the cases with 2 heads. You can have all 3 heads. You can have only 1 head. And there's 3 different ways to have that. And you can have all tails. So there are 1, 2, 3, 4, 5, 6, 7, 8 possibilities. So the probability of B happening is going to be 3 out of 8. A little application, we can use the counting principle to find that 8. It would be, you have two, when you flip a coin, you have 2 options for the first outcome, and then 2 options for the second outcome, and then 2 options for the third outcome, which gives you your 8 total outcomes. So that's one way to count that instead of listing them all out. All right, so and then also there's a way to find how do I get 2 heads out of 3 coins, and so if that would be it'd be like saying how many different words can I make with HT. And what we said prior in our last lesson was that'd be 3 factorial, but I have double H, so over 2 factorial, and that ends up being 3. So we can count the numerator, we can count the denominator, and get 3 out of 8. So sometimes when you have a whole bunch of things and you don't want to list them out, some of these fancy ways of counting, whether using the combinations or permutations or fundamental counting principle, can be helpful to us. All right, part C, throwing a total score of 14 with 2 dice. Well, that's impossible if you think about it, right? So the greatest sum is when you get a 6 and a 6, which would be 12. So there's no way to get 14, and so there's no possibility out of, if you roll 2 dice, we can list them all out, but I'm just gonna, how many different possibilities are there? Well, I have 6 outcomes on the first roll and 6 outcomes on the second roll, so there's 36 total outcomes. So 0 out of 36 would be the probability of C, which is just 0. So not going to happen. Probability of 0 means it's impossible. Number 2 is for you on homework. Okay. Number 3, 3 coins are thrown. List the outcomes which belong to each of the following events. So in all of these, they deal with 3 outcomes, and so I'm just going to refer to what I'm highlighting in green here, because that's the sample space for when you flip 3 coins. Okay. So in there, how many show 2 tails? And so we can list them. So tails, tails, heads, tails, heads, tails, and heads, tails, tails. So it's 3. So here we're just listing the outcomes. We're not asked to find a probability. At least 2 tails. Now, it's going to be important to understand what at least means. At least means 2 or more. So 2, I'm going to write that here. So in this case, 2 or 3. So you'd have the tails, tails, heads, where you have 2. I'm just copying down what I have in A, and then I'm going to add one more, which would be 3 tails, 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 tails. And so you have the case where you have 2 tails, and you have a case where you have 3 tails. You can't get more than 3 because you're only flipping 3 coins. So 2 or more at least means that much or more. At most means that much or less, right? So you include the 2, and you go less. So you can say no more than 2 or 2 or less. Okay. So again, I'm going to list the 2. So we got, these are the cases with 2 tails. And you can have 1 tail. and you can have no tails. So there are 7 cases where you have at most 2 tails. Number 6, if 2 standard dice are rolled, what is the probability that the resulting sum is greater than 3 and less than 11? So again, you want to be able to count what we're working with here. We know that when you roll 2 dice, there's 6 possibilities on each, so there's 36 outcomes. So it's nice to look at all 36 outcomes to answer some of these questions. A nice way to lay that out or to organize that is to create like a table, or kind of like an addition table, where you have the outcomes of 1 on top, so you can have 1 through 6 here, and 1 through 6 here, and then we're looking for a sum, so I'm going to make an addition table. If I was looking for a difference, I'd subtract. If I was looking for a product, I can multiply, those kinds of things. Here I'm looking for a sum, so 1 plus 1 is 2, 1 plus 2 is 3, and just fill this out. And those are all the possible sums. And notice there's some repeats. Like there's only one way to get a sum of 2, but there's 3 ways to get a sum of 4. Or there's, 5 ways to get a sum of 8, and so on. So we want a sum, let's see, greater than 3 and less than 11. So they'll include the 4s, the 5s, the 6s, the 7s, the 8s, the 9s, and the 10s. So we got to count out how many 4s and plus how many 5s plus how many 6s, and so on. We know that the denominator, okay, so let's say the probability sum greater than 3 and sum less than 11, okay, is going to equal something out of 36, and it's however many I highlighted in yellow. In this case, it's probably easier for me to look at what's not highlighted. I got 3 that are not highlighted at the bottom. I got 2 11s and a 12. And I got 3 that are not highlighted up here. So 6 are not highlighted out of the 36. So if 6 are not highlighted, I'm thinking, well, what is 36 minus 6? What are the leftovers, right? And you get 30 out of 36. So reduce that, divide by 6, top and bottom, and you end up with 5 out of 6 for your answer. With fractions, please always reduce. I want to see that on your homework. Notice my notation here, probability of what? I'm just kind of saying probability, and you put in parentheses what you're finding the probability of, some greater than 3 and some less than 11. Showing as much work and just saying what it's equal to. I want you to do that on your homework, okay? 9, if I roll 2 dice, what's the probability the product of the numbers is even? Okay. So we can make a table again. Yeah, but this time look at the products. Sorry, 3. And 1 times 1, 1 times 2, 1 times 3, 1 times 4, and 2 times 1, and so on. So you could take the time and list them out like this. You don't have to do that, but you can. I'll show you another option in a bit, but let's finish this off. So evens, I'm going to highlight the evens. So anything multiplied by 2, so that hits both of these. Anything multiplied by 4, right? And pretty much anything multiplied by an even number, you're going to get even answer. So the ones I highlighted are even numbers coming from even products. And so writing this out, the probability that the product is even. It's out of 36. And again, it might be easier to count what's not highlighted. There's less than this. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 36 minus 9, which is 27 out of 36. Divide top and bottom by 9, and I get 3/4. Now say you didn't want to draw that table. Is there another way to go about this? And the answer is yes. So here's one way. Let's say, because there's less of them, how many different ways can we get an odd number? And because when you multiply two numbers, you can get an odd times an odd. You can get an even times an odd times an even, or an even times an even. Okay, and notice when you multiply an odd times an odd, you get an odd. When you multiply an even times an odd, you get even. When you multiply an odd times an even, you get even. Even times even is even. So what I'm noticing here is if I want to find or if I want to count the evens, I have to consider three cases. But if I want to count the odds, the product that gives odds, there's only one thing I need to consider. And so that's what I'd go after first. And I'd think, well, what are my odd numbers when I roll a die? A 1, a 3, and a 5. Okay, so I got three options for that first roll, and I got three options for the next roll. And so there's very quickly I come at finding that there's 9 different odd products. And I didn't have to write all this out or make this, and I could have very quickly went here and said, well, 36 minus 9, 27 is how many even products I would have. So there's more than one way to count. You can list them all out, or you can try to think of a quicker way. Okay. Next, let's take a look at 13. A standard die is rolled 3 times. What's the probability that all the rolls show a number that's a power of 2? Okay. So probability all rolls are power of 2. So first of all, in this, my denominator, I'm rolling a die 3 times. So there's 6 possibilities for the first roll, 6 possibilities for the second roll, 6 possibilities for the third roll. This is getting bigger than I want to list. If it's 6 times 6, list 36 ways, that's fine. But 6 times 6 times 6, that's getting a little crazy here. So I don't want to list all these, right? And so I wouldn't want to create a table. I'm going to want to think about another method, like how can I answer this or find this numerator instead of having to look at all those different possibilities. Well, what's the power of 2? Well, 2 to the power of 0 is a power of 2, and so that's 1. 2 to the power of 1 is a power of 2, which would be 2. 2 to the power of 2 is a 4. 2 to the power of 3 is 8, but that's beyond what you would roll, because 6 is your max when you roll a die. So really another way to word this is, hey, what's the probability that all that's showing would be a 1, a 2, or a 4? Okay. Well, so if I want the first one showing a 1 or 2 or 4, well, there's 3 possibilities for that first one showing. If I want the second one showing a 1, 2, or 4, well, there's 3 possibilities for the second roll. And there's also 3 possibilities for the third roll. And then I can reduce this to 1 times 1 times 1 over 2 times 2 times 2, which is 1 out of 8. So you want to reason through this. And so what I relied on heavily here is the fundamental counting principle. Right? I was able to count things up without having to list out the whole sample space or all the possibilities. I very quickly was able to just count without having to do that. Okay. Let's take a look here. Let's go all the way to the last one. So this is a finding probabilities. Again, a probability is just a fraction given a table. Okay, and when you're given a table, the first thing you're going to want to do is find the marginal distributions. And the marginal distributions is just a fancy way of saying, hey, find the totals of the columns and the rows and the grand total. And I'm going to go ahead and do that. So 1 plus 2 plus 3 is 6. 4 plus 5 plus 6 is 15. 9 plus 7 plus 8 is 24. 7 plus 1 plus 4 is going to be 12. And then we got 15. And then we got 18. And the grand total here is going to be 45. So if I say, hey, what's the probability of A? Notice, well, there are 12 things sitting under the A category out of the grand total of 45, and so a probability is just a fraction, how many I'm looking for, divided by the grand total. And if you can reduce, and we can divide top and bottom by 3 and get 4 out of 15, right? So 4 out of 15, and we can't reduce any more. On C, we're saying what's the probability of A and B? In this case, you got to, when you say and, it has to belong to both. So how many numbers belong to both A and B? And you can see the way they're arranged, A and B are different columns, and so there are no numbers that belong both to A and B. So when I find this probability, I'm going to say, well, there are no numbers, 0, out of 45, which is just 0. On E, I said A or B. Now, when you say the word or, it's a little different than and you need to have both at the same time happen. Or you take one or the other or both, it doesn't matter. Or is a much more accepting word than the and. And so I have 12 that belong to A. I have 15 that belong to B. There's no overlap between the two, and it's all out of 45. So 12 plus 15 is 27 out of 45. I could divide by 3 and I get 9 out of 15. On on D, we got this new notation. We got this little fraction symbol here. It's what we refer to as conditional probability. We'll talk more about that later, but I'll write it here. And it's saying find the probability of A, but not out of the grand total, just out of F. Okay, so don't look at all 45. Look at how many belong to F. I'm going to rewrite this. So probability of A given F is the way we say that. So my grand total I first look at, I'm going to highlight F here. So this is the row that belongs to F. So you're only allowed to look at the blue. Ignore everything else. So instead of dealing with 45 things, we're just dealing with 24 things. So there are only 24 things that belong to F. Now just look at those 24 things that I highlighted in blue. How many of those 24 belong to A? Only 7. Right here, right? So the 7 there belong to A out of F. So it's a little different type of notation. It's a different kind of probability. We call it conditional probability. Again, we say the probability of A given F would be 7 out of 24. And then F, what's the probability of B given C? So in this one, we're only going to look at everything that belongs to C that I highlighted in green here. So what's the denominator going to be? Hopefully you're saying 18. And then out of those 18, how many of them belong to B? And none. Right? And so we're going to get 0. And so I'm going to let you finish up the rest there. And do the best you can. There's quite a few problems here. Check your answers. If you want to email me any questions along the way, you're welcome to do that. And hope things are going well with you. See you later.